me just tell you what we have in mind here. Three of us, uh, Judy Davis, Stu White, and I have been talking a bit about embodied carbon, and then that it kind of expanded into um, doing the right thing by the occupants of the building with the building materials. And so we'll talk to you a little bit about what we have found so far. Um, and then I hope at the end we can talk a little bit about what SAFE might want to do with the direction we're outlining here. Let me emphasize this is just preliminary stuff, our early digging here, and then we can talk later about where this goes. So I'll start out and I'll give a really short introduction to embodied carbon because I think everybody on this call already knows what that means, and then talk about how embodied carbon and healthy materials factored into the new expansion, the construction of the new Health Wing expansion here at Kendal at Longwood. Um, and uh, as you'll see, that's still pretty basic. There's a lot of missing pieces there, but there are some aspects of it that are interesting. And then Judy will talk about some of the standards involved, and then Stu will talk about environmental product declarations, which are kind of the um, the fundamental basis for um, calculating embodied carbon. So here we go. From my perspective, and this is just kind of off the top of my head definition, I'm claiming that embodied carbon um, is a calculation of the greenhouse gas emissions in CO2 equivalents issued during the production, transportation, and installation of building materials. And as we get into the other two presentations, there'll be a lot of detail around that. Two particularly difficult areas for embodied carbon are the cement and steel that goes into construction. Um, Both of those inherently have high temperature processes and can contribute lots of carbon during their production. There are various things going on to try to come up with alternatives, and some of that is starting to bear fruit, but it's very early days for that. Um, and I wanted to mention wood. Wood is actually, um, as these things go, a good thing in the embodied carbon calculation because the wood itself contains carbon that was extracted from the atmosphere during the growth of the tree. So therefore, that counteracts to a certain degree any carbon that is used in the cutting, the various steps of producing wood materials and then getting them to the job site and then putting them up. So there is actually both a positive and a negative um, component to that. Well, I won't say anything more about that, but I did want to mention the benefit of wood. And in fact, Stu may have more to say about that because he's worked on some projects where that was important. Okay, Longwood Health Center, selection of building materials. Um, in a number of respects, the request for proposals involved, or actually it was at the bidding stage, I think, um, asked the bidders to specify certain things or to ensure that they were included in what they were proposing. So they were asked to specify at least 20 products from 5 different manufacturers that have environmental product declarations um, in their bid, products that they would use in the construction process. And this, I was told, was done as basically a signal to the market that this was important. It wasn't felt that this would necessarily have a huge impact on the embodied carbon, but it was a step in the right direction. And in fact, when I look at the portal where you look up embodied carbon, I don't see very many things there that could possibly be components in our health south wing expansion. But I also haven't asked about that from the contractor or our the manager in charge. Um, the contractor is also required to recycle all the cardboard, drywall, and metal scrap that is generated during the construction process. And they have dedicated dumpsters for those things, and that seems to be happening. One other thing to mention is that the floor joists there's a two-story operation. The floor joists are actually laminated wood. They are specified to be just as sturdy as the steel equivalents would have been, um, and uh, and they have obviously a far lower embodied carbon load. Health of building occupants. So in the bidding process, they were asked to avoid using materials with red list chemicals in 90% of new materials. This is something that you'll hear more about from Judy, and limit the use of volatile organic compounds on the project. And I'm not exactly sure to what extent this had an impact, but it's a step in the right direction. Finally, as a postscript, what we're talking about today is not efficiency, but I know a bunch of people on the call are interested in the efficiency question, and there was a lot of thought that went into that in this particular building, and the guidelines that were generally followed were those of Energy Star for multifamily new construction. Um, and I won't go into that, but that does not address embodied carbon. And LEED, which I guess does in some cases address embodied carbon, at least to some extent, I was told does not have a standard that would apply to this particular construction project. So it was the Energy Star standard, and it resulted in a lot of efficiency measures. So with that, I'd like to turn it over to Judy.
This is just some information. I'm new to Kendal at Hanover, by the way, and have a kind of background uh, as a career in technology, but as a sort of side gig in sustainability. Studied some system dynamics at MIT in the early 80s. Got a late in life degree in sustainability, so it's kind of been a thing that I've been interested in for a long time. This is just some information from Rocky Mountain Institute that I thought would be interesting. Embodied carbon is really something that now is involving a life cycle assessment. And so we're looking at the production, the raw materials, the manufacturing, the transport. And I don't know if this is too small for you to read,
No, it's
but
fine.
the whole life cycle of a product that's used in construction. And what's interesting is that 65 to 85% of the total embodied carbon emissions occurs during this raw material supply and transport and manufacture. And so this is becoming more of an issue when we're looking at constructing or renovating buildings. And Stu is going to talk more about the kinds of products and how the life cycle assessment is done, and the kind of products that you can end up with that are more carbon friendly. But the new sort of standards for LEED are emphasizing quite a bit embodied carbon. So it's kind of be a requirement that there's some addressing of embodied carbon. There's some options for how you can address it in a LEED project, but it's going to be more of a requirement than just an optional way to get points. So you can probably see that during construction, you're emitting another 6 to 10%, 8 to 15% during the use phase, and then in the end of life, 3 to 15%. This first set, I think Stu will talk about, the product phase is sometimes called cradle to gate. And as George said, embodied carbon is calculated and expressed as a global warming potential expressed as carbon dioxide equivalents. And the life cycle analysis is done. Um, and then that's used to create these environmental product descriptions, which are descriptions not only of carbon emissions, but also other types of environmental impacts. So things like acidification or ozone depletion or smog. And let's see, underneath what, which I can't see, is probably eutrophication. So there are a number of environmental impacts that are presented in environmental product declaration. In construction projects, the main things that people are looking at, of course, are using low carbon or carbon neutral or even carbon storing materials. And as George said, if you make beams out of wood, you're using a material that has stored carbon during its growing phase. And so any plant-based materials are good at already storing some materials, some carbon, and then, yes, there's some used in manufacture or use, but the net effect is good. The other ways, of course, that you can reduce embodied carbon are using recycled materials, and then there's some just efficiency and optimization in your design that you can use as well. Again, Rocky Mountain Institute did this analysis, I think this is from 2021, to say that with very little cost premium, you can reduce emissions by 19 to 46%. And so these are the kinds of things that are just sort of making a choice of the materials that you're using and really not having to pay a cost premium. Insulation is the great one, one of the big ones, because you can use cellulose or other plant-based, or I think Stu might have a wool-based insulation. So that's one that gets a lot of reduction. Concrete, there are a number of different products now that are concrete products that are reducing the embodied carbon. I can stick these references in the chat when we're done, but this is what I was using for the basis of what we have here. I just thought it'd be fun to show a couple of slides of some of these mass timber buildings, because this is a relatively new idea to say if we use more wood and less concrete and steel, then we'll have less embodied carbon. And so there are some large projects that have been done with mass timber. And mass timber is just sort of laminated wood to make timbers. Sometimes they're laminated in the same direction, sometimes cross-laminated. This is a picture of, well, at the time, I guess, when the picture was taken, the second tallest mass timber building. It includes a theater, galleries, library, and a museum. It's in Sweden. And LEED version 5, which is coming out this year, should be out soon. There's going to be much more emphasis on embodied carbon. There's also more emphasis on healthy building materials. They've integrated some of the criteria from the WELL certification system, which was originally designed for hospitals or medical facilities, to reflect the importance of building materials on the health and well-being of the occupants. So looking a little bit more toward the occupants. But on the embodied carbon side, materials, there'll be a requirement for some kind of certification or disclosure of embodied carbon in a construction project, a LEED certified project. There are a few different ways that you can do it, that you can kind of document what you've done for reducing embodied carbon. One option was a whole building life cycle assessment. Another is just low carbon low carbon procurement of those um, sort of big ticket items that have a lot of embodied carbon, such as concrete, steel, and aluminum. And then a third way is to just document a number of products that you've used using environmental product declarations, assuming, as George said, that they're available. And LEED is also trying to align with legal requirements of different states. This is pretty much American focused. Um, so it's going to be an interesting thing to see how LEED emerges with this new version 5 standard and to see what changes it makes in how buildings are built. I looked at one environmental product declaration. It's the picture on the right is the first page of a multi-page, let's see, 12-page declaration. And then I just made a sort of list of sort of marketing marketing language in the front on the left, but also in the table on the right on the first page, where in the bold print, those are the required declarations of things like eutrophication and ozone creating potential and things like that, which Stu is going to talk a little more about that. But I was interested in looking at sheetrock when we moved into our apartment. My partner Henry and I started sneezing, and so we're sort of like, what could be emitting some kind of volatile organic compound that we're sneezing over? And that kind of led me just to look at different materials or finishes or glues that might have been used in the apartment. So the sheetrock does have a couple of products that have environmental product declarations. So it includes all the materials that are in it. And then they also have gone for other certifications, which is kind of what you see on the left. The Living Building Challenge Red List, it's Red List free. They talk about recycled content, the Green Guard Gold certification, which is a certification that tests a number of chemical emissions. And then this applies to, we'll give you points for LEED version 4, and it complies with other standards. And I think that's the last of what I have to do. And Stu is going to talk a little more about these product declarations, environmental product declarations.
Environmental product declaration and life cycle analysis, EPD and LCA. Several years ago, I think in the 90s, I was at a Build Boston conference. I attended a session on this emerging science, life cycle analysis, and was just amazed at the immense scale of what they were trying to do, really deep data mining to determine the environmental bona fides of construction products. And I recall thinking that if this ever becomes a useful tool, it will be a monumental achievement. And well, here we are. Um, an EPD, here's a definition. There are a lot of them out there. A standardized document that provides a detailed analysis of a product's environmental impact throughout its entire life cycle, from sourcing raw materials to disposal at the end of its use. An EPD quantifies a product's environmental footprint in a clear and transparent manner. And transparency is key, requiring a third-party verification. I found this from a Japanese climate educational program for children. I wonder if we're teaching this. So here's Judy's slide again. And what I should point out that what we're talking about is a life cycle analysis, not a life cycle cost analysis. That's another very important piece of all this. And I've circled the product phase, that's the raw material, supply and transport, and the actual manufacturing of the product. And this is called cradle to gate because it's at the gate of the factory, ready to be sent to the customer. Cradle to grave is the other one, which we'll talk about, which goes throughout all of these phases. Terrific little video from the Irish Green Building Council. Who knew? It's very good. It's another way of looking at the slide that Judy presented, and it's cradle to gate. You should see that with the blue arrow is the extraction and manufacturing, and then it shows these are all the letter A through transport and installation in the project, and then usage includes maintenance. Oh, sorry, maintenance and um, cleaning, even replacement, repairs, any kind of carbon that's used in that process. And then end of life, disposal, the carbon that's emitted there, or you may even get a plus if you're recycling. But it's interesting that in the Irish program, at any rate, A1 to A3 and C and even D, which we'll talk about, are mandatory from the Irish Green Building Council. In the US, you don't have to do all of these. So this is an example of a cradle to grave, and it goes through, it would include, and you have to declare when you're doing a APD, what you're shooting for, which phases are you including. And highlighted is the product stage, which we've talked about. And you can see down here, A1 through A3, then A4 and A5, then the Bs, which is the use stage, and C, end of life. And then there's this D category, benefits beyond these boundaries, which might result from reuse, recovery, even recovery of energy or carbon. So you may end up with a minus or carbon positive. So this kind of slide full of numbers, I used to always criticize engineers for showing these at presentations. So here I am doing it. I don't see another way. But in the parameter column, Judy talked about these, and it really is amazing to me that they can find numbers for all of this and give us a way to compare materials when we're making selections. So as Judy noted before, up at the top, we're talking global warming potential, and then all these other things that have to do with ozone depleting potential. AP is acidic gases causing acid rain with sulfur dioxide. Eutrophication potential with the increased nitrates causing excessive algae growth. Potential for creation of ozone in the troposphere where we live. Smog. And depletion of non-renewable resources. And water usage associated with the product. So this is where we're looking at I'm still, oh, this is to remind me to say this. It's amazing that they've been able to develop this tool to this point, to me anyway. Um, and for the non-mathematicians among us, including me, uh, this explains, I just want to go back and show, like, this is expressed in kilograms um, of CO2 equivalent. And this notation here is like Greek to me, except it's explained in the next slide. It's a scientific notation. Very simply, if you see 5.6 E 10 plus 3, you move the decimal point 3 places to the right. So 5.6 becomes 5,600 kilograms. Um, and that's where you can find the video. So on to a real EPD. This is the first one. I chose this. This is sort of hands down the one that architects love to specify and clients love to use. It's plant-based. It's carbon positive. There are no downsides. You can practically eat it. Um, th this is just scratching the surface of what's in an EPD. It's 15 to 20 pages long sometimes, but here's the material content of the product. And you can look over here at the what's in this product, and it's renewable bio-based crop, um, and again, one of these numbers, but I've tried to make it easy. You see all these minus signs here. Minus is good. Um, and what this shows is that marmoleum is a carbon, it's really linoleum. We all grew up with it. It's carbon positive. It removes more carbon, that's during its growth stage, than it emits throughout its life cycle. And the company does this 3D drawing, includes this in their EPD. It's really an exemplary operation because it includes in its manufacturing plant its own recycling plant. It uses a lot of its own material um, after um, its life. And and it also, they produce green electricity with solar panels on the warehouses, and that generates the electricity for internal transport by truck and forklifts. And no processed water is used or disposed. So pretty wonderful product. So I decided I'd try to find some classic products in America to compare. It's very tricky comparing because the declarations are for very specific products. For instance, it's quite difficult to find window manufacturers comparing them because there are all kinds of windows. This is a major glass supplier, Cardinal Glass, and I tried to compare this with its competitor, and so I picked flat glass. It's not insulating glass. It's not double pane or triple pane. It's not tinted. You have to be careful when you're comparing. Um, and so here's the summary. The kilograms of CO2 equivalent is over on the right here, 1370. So let's look at one of their competitors is Guardian, and here's their result over here. And now there's that scientific notation. So we can move the decimal point 3 places to the right, and we get 1100, which is pretty close to this one here. So these EPDs are not the only reason, uh, or environmental bona fides aren't the only things that why we pick a certain material over another. Of course, there's cost, the service reputation of the company and so forth, but it's becoming more important. Here's one that really caught my eye. Masonite, old Mr. Mason invented this in the 20s and sort of by accident. And it's another plant-based product. And you've seen it all our lives. We've kind of grown up with this, but they're finding new ways to use it. This is called an I-beam. It's more, it's really, we call it a truss joist. And here are all these numbers over here on the right. But this is showing in the blue what they're declaring, the product stage, the end of life stage, and beyond the system boundary. That's the reuse recycling potential. And notice in down here, if you can see all these minus numbers again. So it's again an excellent product. Here's a clipboard. You've all probably got one of these, and that's my desk. This is Masonite, one of my favorite. It's a very good drawing surface. So George reminded me of my favorite website, climate website, is Architecture 2030. And they are the ones who gave prominence to that date, 2030. 20 years ago, they started this. Anyway, this is a very beguiling product, wool insulation. It really is an amazing product. If reading through this, it sounds like put out by their advertising department, but it's from Architecture 2030. Wool inherently manages moisture, improves indoor air quality by absorbing harmful chemicals, sound absorbing, naturally fire resistant, and will not support the growth of mold. And important from what we're talking about today, wool fibers sequester carbon. And that's because the sheep, the plants that the sheep have eaten, and we are now seeing in their wool. And another one, and I particularly wear a lot of wool because my wife is a knitter and a weaver and a spinner, and so I'm very fond of this product. Now here's another one, is hempcrete. It's a little bit of a misnomer because it unfortunately doesn't have the structural properties of concrete in compression or tension or any structural properties. But again, plant-based and sequesters carbon. So all of this makes me really miss my architectural profession. I hope I have one more project where I can use some of these. So that's it for EPD.